Your objective for lesson 17 is I will practice placing various fractions on the number line. So we're just going to do practice of what we've done for the past few lessons on putting fractions on number lines. And these fractions are not just going to be between 0 and 1. It may be with different whole numbers like the last lesson that we did. So you're going to draw a number line on your board, and the endpoints at the beginning and at the end are going to be 1 and 4. So you know that you're going to have different whole numbers in between those. So you're going to have 1, 2, 3, and 4 on your number line, and make sure that those are equally spaced out. And then you're going to have to partition each whole or each part between your different whole numbers into thirds. So we know our fractions that we're working with today on our number line is going to have a denominator of 3. So go ahead and draw a number line on your board that has 1, 2, 3, and 4 as the wholes. And we're going to figure out what fraction we're going to start with. If we're starting with one whole, you've got to ask yourself how many thirds are in one whole, and be thinking that if we know one whole, the fraction has the same numerator and the same denominator, and we already know that our denominator is 3, then you should know what your numerator is going to be as well. So go ahead and get that number line drawn on your board, and we'll go ahead and put the fractions on there together. Okay, so your number line should look like this, where you've got each section between the whole numbers having 3 equal parts. And we know that our denominator is going to be 3, so we know that our first fraction underneath 1 is going to be 3/3. And then all we have to do is move on to the next fraction. We know that we're going from 3/3, and all we have to do is start counting up. So we know we're going to go from 4/3, and then we're going to have 5/3. 2 wholes is equal to 6/3, and then we've got 7/3, 8/3. 3 wholes is equal to 9/3, and then we have 10/3, 11/3, and 12/3. So you can see what each whole number is equal to as the fractions. And if you remember from the last lesson, I hope that you do, that the fraction line is just like a division line. We know that 12 divided by 3 is equal to 4. We know 9 divided by 3 is equal to 3. And we know 6 divided by 3 is equal to 2. And we know that 3 divided by 3 is equal to 1. So that's always going to help you with your whole numbers. Okay, now we're going to have a new number line on our board. It's still going to have the endpoints of 1 and 4, so it's going to be like the number line that we just did. And we know that with our whole numbers, we're still going to have 2 and 3 because those come between 1 and 4. So if you want to get a number line on your paper where all of your whole numbers are 1, 2, 3, and 4, and then we're going to start putting how many parts we need in between those, and then we're going to place the fractions that you see on the screen on our number line. So if you want to get your number line drawn with the whole numbers, and then push play when you're ready to move on. Okay, so your number line had these numbers on it, and you've had them equally spaced out. But when you look up at the fractions at the top, you have to think about how you're going to put these on the number line. And the one thing I want you looking at closely is the denominator, because we know that the denominator is going to tell us how many parts are in the whole. And we know that in between each whole number on this number line, that is one whole. So that tells us when we have a denominator of 3 that we are going to have 3 different sections or 3 different parts between each whole number. So you need to make your number line look like mine, where you've got 3 different parts between each whole number. Okay, so my number line was a little bit off, so I had to fix it to where it had 3 different sections between each whole number, and I still made it a little bit off, so let me fix it again. Okay, there. So this is what your number line should look like, where it's got 3 different sections in between each whole number. And then we have got to put these fractions on the number line. So we're not putting any other fractions, we're just putting these numbers on the fraction number line. So let's start with 3/3. We know that anytime we have the same numerator and the same denominator, that's equal to one whole. So I know that 3/3 is going to go right underneath the 1. If I were to keep putting fractions on the number line, it would have went to 4/3, 5/3, 6/3, and then 7/3. So right past the 2 is where you would see 7/3, and then it would go from 8/3 to 9/3. So right underneath the 3 is where you're going to see 9/3, and then it would go to 10/3 and 11/3. So right before the 4 is where you would see 11/3. So this is what we're going to be working on today, is just putting different fractions on the number line without putting every single fraction on the number line. But you can still think of it as those fractions are still there, so it will help you count each tick mark to help you determine where these fractions are going to be. Okay, so your new number line is going to have the endpoints of 2 and 5. So our whole numbers are going to be 2, 3, 4, and 5. So you got to make sure that those numbers are evenly spaced out on your number line. And then when you look at these fractions, you notice that they all have a denominator of 5. So in between all of your whole numbers, you're going to have 5 equal parts in your whole. So if you want to go ahead and get your number line drawn, where you've got the whole numbers 2, 3, 4, and 5, and in between each whole number there are 5 different sections, so make sure you draw your tick marks to where you have 5 equal sections. And when you're ready to put these fractions on the number line, you may push play. Okay, so your number line should look like this, where you've got 2, 3, 4, and 5 as your whole numbers. And then in between each whole number, your number line had 5 equal parts. So we've got to find the fractions 12/5, 10/5, 24/5, and 19/5. So the best way to do it is just to figure out what the whole number 2 is going to be. So if you know what this fraction is going to be, then it's going to be easy to determine what the rest of the fractions are, and that's going to be easier for you to find the fractions that we're looking to put on the number line, because we're not putting every single fraction that goes on the number line on the number line. We're just putting the 4 fractions that are on the screen. So since we have this number line divided into 5 equal parts, you have to ask yourself how many fifths are in 2 wholes. So once again, you can think of it as division, and we know that our denominator is 5. So you can ask yourself, what are you going to divide 5 by to give it 2? So it's going to equal the whole number 2. So what divided by 5 is equal to 2? You could also think of it once again just like we did before, where we have 2 wholes, and each one of our wholes has 5 equal parts, and we know that each part in our rectangle is 1/5, and I know that mine aren't super equal right now. I'm just showing you how you could do it if you were trying to figure out what fraction is equal to 2 wholes. So if each one of these sections is 1/5, and I were to shade in all of them, then if this one has 5 parts and this one has 5 parts, then that's 10 parts altogether. So altogether I would shade in 10/5, and I know that this number that goes at the top as my numerator is 10. So 10/5 is actually going to go right under 2. So you need to be putting that on your number line. And then we know that the next one is 11/5. We know that the next one is 12/5. So that's where 12/5 is going to go. And then it would go to 13/5, 14/5, 15/5, 16/5, 17/5, 18/5. And then we will have 19/5 right before we get to the 4 as the whole number. And then we would go from 25th, 21, 22, 23, all the way to 24/5 right here. So this is where you would label all of your fractions on the number line. Okay, so this is going to be the last one that we're working with on our board today. So now your number line is going to have the endpoints of 4 and 6. So you're just going to have the whole numbers 4, 5, and 6. And if you look at these fractions, you notice that they all have a denominator of 3. So your number line is going to be broken apart into 3 equal sections between each whole number. So if you need to push pause and get that number line drawn on your board so we can put the fractions on there, you can do that right now. Okay, so your fraction number line is going to look like this, where you've got the whole numbers 4, 5, and 6, and in between 4 and 5, and in between 5 and 6, you see that we have 3 equal parts. So once again, we need to start with the whole number 4 to figure out what fraction goes there, so it's easier to figure out what the rest of these fractions are going to be and where the other fractions are going to go on the number line. So you have to ask yourself how many thirds are in 4 wholes. So you have to ask yourself, if you have 4 different rectangles and you know that each rectangle has 3 parts, then how many of those parts are going to be shaded in all together? And I know that whenever I have 4 different holes and each one is broken into 3 different parts, that's kind of like saying 4 times 3. And I know that 4 holes is equal to 12 thirds. So 12 thirds is going to go right under 4 holes. And then the next one we would know would be 13 thirds, and then we've got 14 thirds. And then we would go from 14 to 15 thirds, 16 thirds, and then the next one would be 17 thirds. And then we would get to 6, and there is no fraction on the screen that would be equal to 6, because we know that 6 holes would be equal to 18 thirds, and that's not on the screen to put anywhere on the number line. So this is what the number line would look like. And now we're going to be ready for the problem set. If you want to take that out and get that ready and push play whenever you are ready to begin doing the problem set. Okay, so number 1 says locate and label the following fractions on the number line. So we notice that all of these fractions have a denominator of 6. So in between 1 and 0, and in between 1 and 2, and in between 2 and 3, there's going to have to be 6 equal parts. So go ahead and make sure you have that on your paper so we can start putting the fractions where they go. Okay, so the number line would have looked like this, where there are 6 different parts in between each whole number. So now all we have to do is take the fractions and put them where they need to go, and this is starting out pretty easy because we're starting at 0, and that's always an easy fraction to start with. So I know that 0/6 is going to go right here by 0, and I'm going to put it up at the top because it leaves me some room. But since all these other fractions are written up here, I'm not really going to put the other fractions above the number line. I'm probably going to put them right underneath it. So I know if I've got 0/6, I'm going to mark that out because I'm done with that. The next line would be 1/6, 2/6, and then 3/6. So I know that 3/6 is going to go right here. So now I'm going to mark that out. And then I would go from 4/6, 5/6. This 1 would be 6/6. I almost wrote 5/6. And I'm going to mark out that. And then I would go from 6/6 to 7/6, 8/6, 9/6. So 9/6 is going to go right here. So I'm going to mark that out. And the last one that I have left to put is 12/6. So I would go from 9/6 to 10/6, 11/6, and then 2 would be 12/6. So that's where all of these fractions go on the number line. And now we're ready to move on to number 2. Once again, it says locate and label the following fractions. So we see that all of these fractions have a denominator of 4. So on our number line, we're going to have to make 4 equal sections. And then we're going to have to find where these fractions go on the number line. This number line is starting with a 1 instead of a 0, so we'd have to figure out what that 1 whole is equal to. We know that all of our fractions have a denominator of 4, so you'd have to ask yourself how many 4s are in 1 whole. And once again, we know that with 1 whole, our fractions are going to have the same numerator and the same denominator. So that out of all of these fractions, the one that has the same numerator and the same denominator is 4/4. So I'm going to mark that out, and I'm going to put it right above the 1 whole. Then I'm going to start counting to see where my other fractions go, and it looks like 6/4 would be next, so I would go from 4/4. This next one would be 5/4, and then we would have 6/4. So right here is where we're going to have 6/4. I'm going to mark that out, and then we would have 7/4, and 2 wholes is equal to 8/4. So we're going to put that right above the 2. And I'm going to mark out 8/4, and then we would go from 9/4, 10/4, 11/4, and then 3 would be 12/4. And then the last one that we have to find is 16 fourths. So I would go from 12 fourths to 13 fourths, 14 fourths, 15 fourths, and then 16 fourths. So when you're looking at this number line, what do you notice with all of our fractions, or the majority of our fractions? What I notice from the majority of our fractions is that most of them are equal to whole numbers. The only fraction that is not equal to a whole number is 6 fourths. So 4 fourths, 8 fourths, 12 fourths, and 16 fourths were all equal to whole numbers on this number line. Okay, this one has got a lot of different whole numbers in it. Starts at 2 and ends at 6. All of these fractions have a denominator of 3, so that tells me that in between each whole number I'm going to have 3 different parts, and each fraction has a denominator of 3, so whenever we start at 2 we have to ask ourselves how many thirds are in 2 wholes, and I know that whenever I have 2 wholes, that's going to be the same thing as 6 thirds, because I know that 6 divided by 3 is 2. And I also know that if I had 2 rectangles drawn and that each one of my rectangles had 3 parts, then that's the same thing as saying 3 and 3 together, which is 6. So I also know that that's how I got 6 thirds. So now I'm just going to keep counting to see where the rest of my fractions are going to go. So if this is 6 thirds, I would go to 7 thirds, 8 thirds, and then here would be 9 thirds. So I'm going to put 9 thirds above 3 wholes, and I'm going to mark out my 9 thirds. Then I would go from 10 thirds, and then this next one right here would be 11 thirds. So I'm going to mark out 11 thirds, and then I would be at 12 thirds, 13 thirds, and then this part right here on the number line is 14 thirds. Then we've got 15 thirds, 16 thirds, 17 thirds, and then 6 wholes is equal to 18 thirds. So now I've got those two fractions done, and I'm done with the big front side of this problem set and ready to move on to the back side. Number 4 says, for a measurement project in math class, students measured the lengths of their pinky fingers. Alex's measured 2 inches long, and Jeremiah's pinky finger was 7/4 inches long. Whose finger is longer? Draw a number line to help prove your answer. So the one part on this number line or the one part in this problem that helps us figure out our number line is the 7/4, because that tells me right there that 7/4, I'm going to have 4 different parts in between each whole number on my number line. So what we're going to need to do is we're just going to start with 0 on this number line, and we are going to go to 2. And we know that in between there's also going to be a 1. So on your number line, you need to make it look just like mine if it's not just like mine. And then we're going to figure out where or what fraction is equal to 2 inches and what fraction is equal to 7/4 inches. So we know that in between each whole number there's going to be 4 equal parts, so we're going to make our different parts on our number line. And then we're going to start filling in fractions to see what 2 wholes is equal to and to see what 7/4 is equal to. So I know that 0 is going to be 0/4, and then I'm going to go from 1/4, go to 2/4, 3/4. I know that 1 whole is 4/4. So to be honest, we really maybe didn't even have to start with 0. We probably could have started with 1, since we know that 4/4 was where 1 whole gave us, and we had to get to 7/4. So we probably could have started at 1 and then made our number line go to 2. But let's keep going to see where 7/4 is. So there we've got 5/4 and 6/4. And then right here is 7/4, and we know that whenever we get to 2 wholes, that's going to be equal to 8/4. So we've got 7/4 right here, and then we've got 8/4 right here, which is also equal to 2. So the question said, whose finger is longer? So Alex's was 2, so I'm going to write Alex right here. You also need to do that on your paper so I can see exactly what we're talking about. And then Jeremiah's was 7/4, so I'm just going to abbreviate that and just put Jer. So you can see on the number line whose finger was longer because um, 8/4 comes after 7/4, and that tells me that that's longer than 7/4 is, and I know that 8/4 is actually the same thing as 2 inches, so now all we have to do is answer this in a complete sentence, saying whose finger was longer. It said draw a number line to help prove your answer, so it didn't really say that we had to explain our answer, it just said draw a number line to help prove your answer, and since we circled 7/4 and put that that was Jeremiah's, and since we circled 8/4 and 2/4 and put that that was Alex's, this number line pretty much explains why we're putting the answer that we're putting. So Alex's finger is longer, and that's all we have to put because our number line explains why we are putting that. Okay, so now we're ready to move on to number 5. It says Marcy ran 4 kilometers after school. She stopped to tie her shoelace at 7/5 kilometers. Then she stopped to switch songs on her iPod at 12/5 kilometers. Draw a number line showing Marcy's run. Include her starting and finishing points in the 2 places where she stopped. So since it said include her starting and finishing points, we have to start at 0 because anytime you're starting to do something, you're starting at 0 and then you go on. And since it said she ran 4 kilometers, that's a big key point right there. I know that my number line is going to go from 0 to 4. So our number line on number 5 is going to be a little bit longer, and it's going to start at 0 and it's going to go to 4 because it said that she ran 4 kilometers. So I'm going to go from 0, 1, 2, 3, 4. Now mine aren't evenly spaced out, so I'm going to go and make them more evenly spaced out. And when you look at the fractions that are in this problem, I see that they have a denominator of 5. So that also tells me that in between each whole number, if I've got 0 here, here's 1 kilometer, 2 kilometers, 3 kilometers, and 4 kilometers, in between each one of these whole numbers, I'm going to have 5 different sections. So on your paper, you need to make sure that in between 0 and 1, and in between 1 and 2, and in between 2 and 3, and in between 3 and 4, that you have 5 different sections. Since there's a lot of different sections on here, we're not going to worry about writing every single fraction on this number line. We're going to worry about just putting the fractions that they're talking about in the problem. So we're just going to be worried about finding 7/5 and finding about 12/5 and where those go on the number line. And then all we have to do is put the 2 places where she stopped. And since we're not having to answer a question on here or write anything in a complete sentence, whenever we're labeling number 5, we're not just going to want to put the question or the fractions, but we're going to put what those fractions stand for. So since we're starting at 0, that's always a good number to start at because our fractions are easy starting at 0. So I know that 0 is 0/5. I also know that 1 is 5/5, so instead of counting all these fractions in between here, I'm going to start at 1, and I'm going to say that this is 5/5. Then this next line would be 6/6, and this next line would be 7/5. So I'm going to go ahead and put 7/5 right here. Then I would go from 8/5, 9/5, 10/5, 11/5, and this line right here would be 12/5. And I know that 7/5 was to tie her shoelaces, so I'm going to write tie shoelaces right here. And then I know that 12/5 was to change the song on her iPod, so I'm going to put iPod on 12/5. So we labeled the number line from her starting point to her finishing point. We also labeled where she tied her shoelaces, and we also labeled where she had to change the songs on her iPod. So when you look back at the question, it said draw a number line showing her run, include the starting and finishing point. So we started at 0 and ended at 4, and then put the 2 places where she stopped, and we put 7/5 and 2/5 and what those 2 places stood for. So we have answered all parts on number 5, and we are ready to move on to the exit slip now. So whenever you are finished with your exit slip, make sure you bring that to me.